In the past two videos, we looked at the cases when we have one point of intersection on the x-axis. That's when we had a max or min point on the x-axis. Then we looked at the general case when we have 2 points of intersection on the x-axis and how to identify those points. In this video, we're going to look at how to identify when there are no points of intersection on the x-axis. So we're going to need to use a quadratic formula, as you see here, minus b plus or minus square root of b squared minus 4ac over 2a. And the a, b, and c are directly related to the quadratic equation y equals ax squared plus bx plus c. So you've probably seen this in some form. Let's remind ourselves where this equation even comes from. So here's our quadratic equation with y set to be equal to 0. We set that one equal to 0 because we want to find the x values when this is true, when y is equal to 0. Because when y equals 0, then we're on our x-axis. So we set it equal to 0. Then we can divide by a, so we get x squared plus b over ax plus c over a is equal to 0. And we see if we just look at the first two terms, we have x squared plus b over ax term. We're going to want to look at this component and see if we can rearrange it so that we can identify this equation. So if on a side note, we recognize that x plus b over 2a squared gives me my first two terms the same, x squared plus b over ax, but a separate third term, right? Here we have c over a. Here, when I square b over 2a, I get b squared over 4a squared, right? So I'm going to try to take advantage of the fact that I know this is equal to 0, and then I know this relationship here. So I'm going to combine these two concepts. So I take x plus b over 2a squared, and then I expand it in the form of the quadratic equation here, and I need to match it to this side here. So I want to drop out the ca, so that's why I have a negative c over a. And I am missing a b squared over 4a squared. That's why I added here, right? So this is, the expansion of this is this form. I have the x squared plus b over a x term right there. And then I drop out the c over a component right there. And then I re-add the b squared over 4a squared. So why did I do that? Well, I want to see this form come in. This I know is equal to 0 because I'm setting y is equal to 0. So I can drop out that term. Now I have a new relationship between x plus b over 2a squared. We have this is equal to this form, and I'm going to just rearrange it so it matches up here. So I'm going to move b squared over 4a squared first, minus c over a. All right, so these terms here are going to be used to help derive this component. So if I take the square root of x plus b over 2a squared, I'm going to get a positive x plus b over 2a. If I take the square root on this side, it can be plus or minus, right? So plus or minus square root b squared over 4a squared minus c over a. Then I can move b over 2a to the right side of the equation. I get x equals negative b over 2a plus or minus square root b squared over 4a squared minus c over a. We do common denominators. I'm going to get 4a squared. So then c needs to be multiplied by 4a. So that's what's going on here. And then 4a squared, the square root of 4a squared is just 2a. So I can pull that out of the square root and have a common denominator of 2a. And then I'll get my minus b plus or minus square root of b squared minus 4ac. So what does this tell me? So if I'm looking for the points of intersection, I can just use this quadratic formula to find it. And something interesting happens when we have no points of intersection. We can still use this quadratic formula to help us identify that is the case. Now here we have the equations that I showed in the previous video. Examples of when there's no intersection points, when there's only one intersection point, and when there are two intersection points on the x-axis. So we can use one of these equations as an example and apply it to the quadratic formula. So I'll do it for this one, and then you can do it for the other sets of 3 in each of these categories, right? So Let's first look at the case when there are no points of intersection. So our goal is to use a quadratic formula to help us identify which case we actually have. So this case is the one that we're focusing on in this video, but the other cases can also use the quadratic formula to help us identify it. We've shown other methods for the simple case. This one is for this for a general case. All right, so here y equals x squared plus 5x plus 8. So we're going to start here. My a value is 1, my b value is 5, and my c value is 8. So I can plug it into this quadratic equation. So I have this section highlighted because you'll see that this section is the criteria that will help us determine which of the three categories we actually have. So I have minus b, minus 5, plus or minus square root b squared, 5 squared, minus 4ac, minus 4 times 1 times 8 over 2a, 2 times 1. All right, so I clean this up. I get minus 5 plus or minus square root of 25 minus 32. I get square root of negative 7 divided by 2. So the square root of a negative number is an imaginary number. You may have seen this in class with a little I describing it, right? So that's used for other purposes. So it actually is a useful number, but it also means that there is no real number intersection with the x-axis. So in case like this, we say there are no points of intersection with the x-axis. And all I need to look at is this term right here. So if b squared minus 4ac is negative, then I know there are no points of intersection. So it's a really easy check, right? Because you just need to use the b, a, and c constants to help us identify it. So another way of saying that, we can say b squared minus 4ac is less than 0, or I can say b squared is less than 4ac. Then there will be no points of intersection. So quick check is to just do that. So I want you to do the same thing for these three equations and verify that you get the same come to the same conclusion, that b squared is less than 4ac for these cases. All right, let's for the sake of completeness do the same thing for the 1 point of intersection and the 2 points of intersection. So here's the example I'll do with you, and then you can do the same thing for these three examples. X squared plus 8x plus 16. I have a equals 1, b equals 8, and c equals 16. So I get negative b, which is 8, plus or minus square root b squared, so 8 squared, minus 4ac, 4 times 1 times 16, over 2a, 2 times 1. So this gives me negative 8 plus or minus square root 64 minus 64 divided by 2, and this gives me x is equal to negative 4. Now we've done this, I think we've done this specific problem in the past, right, where we get x, the quantity x plus 4 times x plus 4, or x plus 4 squared, right? And what was that resulting? That's a minimum at x equals negative 4 and y equals 0, right? So in this case, right, we have a minimum or maximum at along the x-axis. So in order for that to be true, this plus or minus component needs to be 0. So b squared minus 4ac needs to be equal to 0, or b squared must equal 4ac. In that case, then there will be one point of intersection on the x-axis, right? So do the same thing for these three example problems, or these three equations, and verify that b squared minus 4ac is equal to 0, or that b squared is equal to 4ac. All right, and then the last one, which we looked at in the last video, here we have 2 points of intersection. So when we apply this quadratic formula, we should see that the b squared minus 4ac is not less than 0, and it's not equal to 0, but it will be greater than 0. So b squared will be greater than 4ac. And so we can look at that from this example problem. X squared minus 4x plus 3, so a equals 1, b equals negative 4, and c equals 3. Right, so we got negative b, so minus minus 4, plus or minus square root of b squared minus 4 squared, minus 4ac, 4 times 1 times 3 over 2a, 2 times 1. So we got 4 plus or minus square root 16 minus 12 over 2. So 16 minus 12 is 4, so square root of that is 2. So I'll get 4 plus 2 is 6, divided by 2 is 3, or 4 minus 2 is 2, divided by 2 is 1. So both 3 and 1. And we can see from the graph that this equation, the red curve, intersects the x-axis at x equals 3 and x equals 1. So if b squared minus 4ac is greater than 0, or b squared is greater than 4ac, there will be 2 points of intersection. So repeat this process for these three and verify that you see that b squared is greater than 4ac, and because of that, we see our 2 points of intersection on the x-axis.